Hey everyone, in this video we're going to look at horizontal and vertical lines. So we're going to jump right into it. In the graph below we have a horizontal shown on the left, and on the right we have a vertical line. So we're going to kind of gather some information about those first. So on this graph on the left first, what's true about all the points? Well, we have 2 points highlighted. So one of those points here is the point -2, 3. While the other point is at 4, 3. And I could go and get all the other points if I really wanted to. Like I know that this point is at 0, 3, 1, 3, 5, 3, -5, 3. So the big thing I should notice about all these points on this horizontal line is that all the y values are 3. So they all have the same y value. Okay, so for my y coordinate of every one of those lines, it's going to be 3. And just like I said there, every single coordinate has y equal to 3. So the best way to make that equation is just say that y is equal to 3, right? Because every point, no matter what I have, is y equal to 3. The x's are changing because we're going left and right, but it's not going up or down at all. Okay, so if we were to calculate the slope just to see if that all works out, if I took the 2 points that we started with here, the -2, 3 and the 4, 3, we would have 3 subtract 3 and 4 subtract a -2. So if that's the case, I have 0 divided by 6, which you can do. 0 divided by 6 is just 0. So my slope would be 0. And that should make sense because if I look back to that line, the slope's not going up or down at all. It's just staying flat. So it's going to be 0 there. Okay. Now I'm going to take a peek over here at my vertical line. So same kind of thought process. We have the point here 2, 5. I have 2, 4. And I have the point 2, -1. And I could look for more, right? I could have the point 2, 0 or 2, 2 or 2, -4. In this case, all the points are going to have the same x value. So what's true about all the points on this line? They have the same x value. And because they all have the same x value, that means vertical lines are given the equation with x equals, and in this case, it's x equals 2. Now, vertical lines have something interesting that happens when we go to calculate their slope. So we're going to take those 2 points, 2, 4, and 2, -1. So I subtract the y's, and I subtract the x's, so change in y over change in x. I end up with -5 over 0. Now, this time around, we run into a problem. So to have 0 in the denominator, that's not okay. Because we can't divide by 0. Because think of it, the whole point of division is to break up things into even groups. Well, if there's 0 groups, then this just falls all the way apart. Now, you can plug that into your calculator. If you try -5 divided by 0, you'll see that you get an error message. It won't allow you to divide by 0. This is known as an undefined slope. Okay? And I think we've actually talked about it in class already at this point. But we might have asked Siri what 0 divided by 0 is. If we did it in class or you don't remember that happening, pause the video real quick, pull out your phone, and ask Siri, what's 0 divided by 0? And then hit play when you're done. Okay, so either you hit pause and you're back with us, or you didn't have to leave because you remember what happens. When you ask Siri what 0 divided by 0 is, she straight up roasts us. She tells us that we have no friends, that Cookie Monster has no cookies. She's very passionate about it because it's true, though. Dividing by 0 is not okay. There's never a way that that's going to work, so it's always going to be undefined. So any vertical line that we have is going to have an undefined slope. But the 2 biggest things that we should have taken away is now that we can write the equation of these lines, a horizontal line is always y equals some constant number, whatever the same number repeating is, just like whatever the vertical line has as x is the constant. So when I go to do the next problem, it says which of the following equations represents a vertical line. So before I get any further, I should know vertical means x equals. That passes through the point positive 5, negative 3. So we know that that coordinate is in the form of xy. I'm going to take the x value, 5, and that's going to be choice 2. Okay? If it was horizontal, we would have picked choice 1, but automatically 3 and 4 are off. Vertical and horizontal lines, they don't have slopes, right? They either have 0 or undefined, so no good for 3 and 4. You shouldn't have both in there, no way. But it's a vertical line that passes through that point 5. Okay, so that being said, exercise 3 shouldn't really be an issue for us. I think we should pause the video here and try to write the equations of each of these lines from A through H. So pause the video, write in your answers. When you come back, we'll go over them, or I'll go through them, okay? So hit pause, and then when you're ready to go recap, hit play. Okay, welcome back. So as I'm going through these here, A is a vertical line, and each point has the same x value, so x equals 3. And the next one, another vertical line. This time we have x equals negative 4 for every point. For C, horizontal line, so we have y equals, it's 1 under the y-axis, so we're looking at y equals a negative 1. For D, another vertical line, so we're looking at x equals 5. E is horizontal above above the x-axis. So in this case, we're looking at y equal to 4. And then one more horizontal, we have y equals 2. So when we're pulling them off the graph, we're literally just looking for if it's horizontal or vertical. Vertical is x equals, horizontal is y equals, and then you just pick an x value or a y value from it. So they all have the same x or y value depending on the type of line. Same concept here in G. It's telling us that we have a vertical line. So automatically when I see vertical, I should be thinking x equals, right? It's running up and down. X equals negative 4. So when we look at the point, we just pull the x out value from it. Same thing in H, but this time we're looking for an equation of a horizontal line. As soon as you know it's horizontal, we'll jump to y equals, and we'll take the y value that was given, y equals 2. Now in the next part of this, we're going to connect it to what we were doing with the equations of the lines already. So we can determine the equation of the line that passes through the points 4, negative 3, and negative 2, negative 3. So what we could do is we could first look at the slope, right? We could take negative 3, subtract a negative 3, over 4, subtract a negative 2. I end up with 0. Double negative makes a positive, over 6, and I get 0. Okay, so I have something with a 0 slope. So I should know automatically that that 0 slope means that my line is horizontal. Since my line is horizontal, it's y equals. And if I would have just looked at this, I would have seen that they had a repeating y value, so I could have automatically jumped to y equals negative 3. I do want to take a quick second and show you guys something though. So we know our slope was 0. Let's say if I went to plug into y equals mx plus b, right? We know that's our equation of a line. If I were to plug in either point, so let's say negative 3 equals, my slope is 0. My x value could be either one, right? So if I plug in the 4 plus b, negative 3 is equal to 0 times 4 is 0 plus b. That means my y-intercept is b. So it's like I have y equals 0x minus 3, but anything times 0, so anything in for x would have canceled out. That's how we end up with the equation y equals negative 3. So I could plug it in and do all the same stuff, but it's a lot of work when I just realized that I have a repeat in the y's. That means it's y equals negative 3. It's going to be a horizontal line. It's going to have a 0 slope. Okay, so I don't have to do all the stuff I just did in the purple. I'm just showing you why if I plugged it into that equation, it still checks out. I could do that same kind of thought process here in 5. We'd have -5 subtract 3 over -1 subtract a -1. So I'm looking at -8 over 0. But here's my problem. This is equal to an undefined slope. As soon as I see it's undefined, we run into an issue. This is vertical. Because it's vertical, I know it's x equals, and I might have already noticed that x equals -1. So that would have been the line there. I'm not even going to try to plug it in because undefined, we don't have a number to plug in for the slope. We just know that there's an error. So that's why undefined is vertical. It's going to be x equals. But if you saw that the x equals the same thing, you don't have to go ahead and plug it in. Okay, last one. So in exercise number 6, we want to sketch the region bounded by 3 lines whose equations are given below. Label each with its equation. Find the area of the triangular region enclosed by the lines. For the first equation, you can use your graphing calculator to create a table of values or use the properties of lines, including the slope and the y-intercept. So in here, first thing, I have a slanted line. If you see x and y, we know that this is slanted. We know the slope is 2 and the y-intercept is at -4. So we know for that first one, I'm going to start my graph at -4. That's what happens with the y-intercept. It's on the y-axis, and that's where we start our graph. Then my slope is up 2 over 1. So I'm just counting up 2 over 1 each time. And I could count down to 1 to the left. But that first line is going to run through here. Okay, and I have to label it so it's y equals 2x subtract 4. So this is my first equation. Next equation was x equals -1. That's a vertical line. As soon as we see x, we know it's vertical. So we're going to where x is equal to -1, right? So all these points are the x value being equal to -1. I'm going to label that one as well. And finally, we have a horizontal line because it's y equals. So we go to where y is equal to 2. So y is always equal to 2 along this spot here. I'm going to label that. Now we're going to shade in the pieces. So it just asks us to shade. So I'm just going to pick color here and shade that triangle on inside there. So we're trying to find the area of that triangle. So my area is equal to 1/2 base times height. Now remember, back from when we've done this before, your base times height, your height always has to kind of be making a 90-degree angle. So what I'm going to do here is this piece, that's going to be my height. That's how big this is, right? So that's my height, and I'm counting the amount of boxes there. So I'd have 1, 2, 3, 4, 5, 6, 7. So 7 is the height. The base is going to be this piece here. So I'm looking at 1, 2, 3, 4, 5. And then I just plug in here. Oh, you know what? I'm just looking quick. I counted wrong on that first one. I don't know why I didn't decide to draw this long enough, so bear with me there. But this piece here is actually all the way to where that intersection is. So that's actually 8. Okay, so I've counted that. And then I just put that right in the calculator and multiply. And we're going to end up with 1/2 times 40. So we end up with 20. And there's no units in here, but it's going to be units squared, because remember, units are always squared in area, or square units. But in this case, we find that triangle, the base and the height have to make a 90-degree angle, right? They have to be perpendicular to each other. They have to make that 90-degree angle, because when you're getting your height taken, we always stand up straight. So we make a perpendicular line with the ground. But in this case, we plug into that formula. That would be everything. All right, guys. Thanks for watching. We're going to do some more practice in class tomorrow. See you then.